Hey all, today we're going to review the important information about triangles. We're going to stay away from right triangles today. I'm going to make a whole review on right triangles specifically. So today let's talk about some relationships that exist within triangles and also between two triangles. So first things first, something you're all very comfortable with, and that is that all of the interior angles, so all the inside angles of a triangle add up to 180 degrees. So if I come down and look at this triangle, uh, this interior angle and this one all add up to 180. So if I have two inside angles, I could always find the third by writing the equation that all these angles equal 180. Another relationship that exists is between an exterior angle. So this angle is on the outside or the exterior of the triangle. And this angle x is equal to these two, what we call remote interior angles, added together. So if I add 72 plus 45, I'm going to get the value of x. So I don't need to find the third angle here. All I need to do is add these two inside angles, and it's equal to this exterior angle. And that's always true no matter which exterior angle we have. It's equal to the two angles added together. If you can remember back, we ordered the sides and the angles in triangles. Sometimes from biggest to smallest, sometimes from smallest to biggest. The relationship that exists is that the biggest angle, so if we're down here on the left triangle, the biggest angle is across from the longest side. So because side AB is the longest, that makes side or angle C the biggest. On the flip side, if we know all the angles, here we have the biggest angle. Well, that means that the longest side is across from it. So since C is the biggest angle in this triangle, side AB is the longest side. So we can use that information to order side lengths, order angle measures from smallest to biggest, biggest to smallest. Of course, you always want to make sure to be careful which order that you're being asked to put them in. We talked about figuring out if a triangle could exist given three side lengths. So the rule here is to take the two smaller sides. So I'm looking at this triangle. I want to know if this triangle could exist. I take the two smaller sides, 3 and 5, and when I add them together, I get 8. This value 8 needs to be bigger than the third side. So since 8 is bigger than 7, then it is possible for this triangle to exist. If these two smaller sides add up and that's equal to the third side, then the triangle cannot exist. If 5 plus 3, when I add them together, is smaller than the third side, then that triangle also cannot exist. Sometimes I want to find the possible length of a third side when I only know two sides. So I think that's pretty simple. I take the two side lengths that I have. X is the side I want to know, the possible third side length. That goes in the middle here. So the length is going to be between two numbers. I find those two numbers by first subtracting the two sides. So I do the big one minus the small one. 9 minus 5 gives us 4. And then I add the two sides. 9 plus 5 gives us 14. So that means that the third side, this side X, that I highlighted in purple, needs to be bigger than 4 and smaller than 14. So it's going to be something that's bigger than 4 but smaller than 14. It could be anything between those two numbers. It can't be 14 and it can't be 4. It's got to be bigger than 4, smaller than 14. We also talked about isosceles triangles this year. Isosceles triangles have two congruent sides. So remember that these symbols right here mean that those sides are congruent. And in an isosceles triangle, the angles across from those sides, so angle C and angle B, are also congruent. Now I think it's important to point out that an isosceles triangle doesn't always have to be in this orientation. Sometimes it might be like that. Still, those two sides are congruent, and B and C are congruent. It might be upside down. Could be sideways. Okay, so make sure to note, if you're given a problem, which sides are actually congruent to each other. We talked about some proportions that exist in triangles. So if I have an angle bisector, right here is an angle bisector, that means that this angle right here and this angle right here are congruent. Then I have some proportions that exist, and if you recall from the lesson a while back, I said that the fractions kind of write themselves. And I'm going to get rid of this x here that I don't need. So the fractions kind of write themselves. If I look, I have x over 8 and 6 over 11. I can set x over 8 equal to 6 over 11. I can write it this way. I can do 8 over 11 and x over 6. I can set those two fractions equal and solve for x. So it doesn't matter which way you do that, as long as you're consistent. Over here, similar situation. I could do x over 4 equals 6 over 7. Or I can do x over 6 equals 4 over 7. Or 6 over x equals 7 over 4. So there's a bunch of different proportions you can write, just as long as you're consistent. And I should tell you that this line that goes through the triangle is parallel to that side of the triangle, and that's what creates this relationship. This relationship on the left is created by an angle bisector. So now we're getting to the big part of the triangles information, and that is talking about congruent triangles. Two triangles are congruent if all three pairs of corresponding sides are congruent to each other. So I have 1, 2, 3 pairs of congruent sides, and then I have also corresponding angles being congruent. So just remember that the number of arcs in each angle tell you which angle is congruent to which other angle. So you can tell which parts correspond by looking at the names of the triangles. So angle A and angle D are congruent. Angle B and angle E are congruent. Angle C and angle F. That also means that segment AB and segment DE are congruent, and so on and so forth. So you can look at the names of the triangles and know which sides and angles should correspond. And that's just written down here. I think the big idea here is to understand these triangles and maybe this name. So maybe this portion of the page is the most important. And then what's even more important are the ways to show that triangles are congruent. There's a lot of words here. I probably would get the method name, so side, 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 or side, angle, side, and I would get the example. So if I have two triangles and all three sides are congruent, all three pairs of sides, then I know the triangles are congruent by side, side, side. If I have two pairs of sides congruent, and then I have the included angles that are congruent, so notice that these angles are between the pairs of sides I'm using, then it's side, angle, side. If I have two pairs of congruent angles and then the side between those angles, just like that, then it's angle, side, angle. Angle, angle, side is similar. I have two congruent angles again, but notice that the congruent sides are not between the two angles. So that's an angle, angle, side. Again, this is how we prove these triangles to be congruent to each other. And last but not least, if I have two right triangles, and I know that the two hypotenuses of those triangles are congruent, and then I know that one pair of legs are congruent, then I have hypotenuse leg, and I know those two right triangles are congruent. So again, I would get the name of the theorem and then copy the picture. These are all the ways we can show that two triangles are congruent to each other without knowing every piece of the triangle. Very, very, very important information. Similar to that would be similar triangles. Let me go back real quick and highlight that that's the symbol for congruence. And now notice the difference. The symbol for similarity is just the little squiggly line. These triangles aren't going to be the same size. They're going to be similar, though. All the angles are going to be congruent to each other. So A and D, B and E, C and F. They're congruent. They're the same angle measure. The difference here is that the sides won't be the same length, but they will be in proportion. So I go to the corresponding sides, like 6 and 12, and I can write a fraction. 7 and 14, I can write a fraction. 10 and 20, I write a fraction. If the two triangles are similar, like they are in this picture, then all three of these fractions should simplify to be the same thing, and they do. They simplify to be 1/2. So that's what exists if we know the triangles are similar. We also might want to show that they're similar. Again, the important pieces of information from this page are the name and then the pictures. So if I know that two pairs of congruent angles exist in two triangles, then I know that those two triangles are similar triangles by angle, angle. Here I have side, side, side. So if I know that all three pairs of sides, if I can write those fractions and those fractions are all equal, then I have side, side, side similarity. And last but not least, if I have one pair of angles between two pairs of sides, and those pairs of sides, I can write the fractions and those fractions are equal, then I know the triangles are similar. So that was a lot of information, several units in one lesson. We will definitely do a lot of practice in class.